This is the States of Matter flip lesson. You could also call it the Phases of Matter lesson. But in this lesson, we are going to talk about the difference between solids, liquids, and gases. All of the information you see on the whiteboards behind me, you will need to make sure that you get this copied into your spiral notebook. The title of this entry is going to be States of Matter. So we're going to start with a solid. All right, a solid has a fixed volume and shape, which means it is in a cube, it is in a circle, it is in a tube of some sort, but it does have a fixed volume and a fixed shape. The particles or molecules that make up that solid are tightly packed together. All right, an example would be an ice cube. If you think of an ice cube, it's in a block. The molecules that make up that ice cube, which we know are hydrogen molecules and oxygen molecules, are tightly packed together. They're not moving around very much. As you transition to a liquid, liquids are slightly different because they do have a fixed volume, but they take the shape of their container. So if you pour a liquid into a cup, a bowl, a dish of some sort, the liquid will take whatever shape of the container you pour it into. In a liquid, the particles are moving a little bit more freely, and if you think about a glass of water, it's a lot different than an ice cube. An ice cube is basically going to just sit there because the molecules are really tightly packed together. In a glass of water, it has a little bit more movement to it because still hydrogen and oxygen, but the particles are a little further apart, and we're going to talk about why that is in a moment. And finally, a gas. It's different than the other two. It has no fixed volume or shape. All right, it can go in any direction that it wants to go. The particles move most freely in a gas. All right, the particles are moving around all sorts of different directions. An example of this is, we're sticking with water, is steam. Now we're going to talk about how we transition from one type of matter to another, okay? So we're going to start with transitioning from solids to liquids. We call this transition a melting point. At what temperature does it move from a solid to a liquid? All right, an example, water's melting point is 32 degrees Fahrenheit or 0 degrees Celsius. So when water hits the temperature of 32 degrees, it begins that melting process. As it moves to 32, 33, it melts a little more quickly, okay? And in this example, I've drawn a box and I have my ice cube in here, and all these little circles represent a molecule, all right? Hydrogen molecules and oxygen molecules. If we add energy or heat to this, the particles start to, almost dance and get to move a little more freely. So the heat causes these particles to gain energy and they start to move a little more rapidly. So you'll notice in this picture, when it starts to transition to a liquid, you have the particles not so tightly packed together like they are here. Okay, and this is what will happen as you melt an ice cube and move it into a liquid. All right, if we want to continue moving, once we have a liquid, how do we get to a gas? This is called the boiling point. We're sticking with water. Water's boiling point is 212 degrees Fahrenheit or 100 degrees Celsius. So here is our liquid. We have this liquid. Again, we are adding heat energy. As you add energy, those particles start to move even faster, 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 and then these particles start moving in all sorts of directions. All right, the more heat you add to it, the quicker those particles are going to start to move. What if we want to go in reverse? All right, now that we've created a gas, how do we go from a gas to a liquid and then back from a liquid to a solid? Okay, to go from a gas to a liquid, remove heat. All right, so you're cooking a pot, you have a pot of water on the stove, you add the heat, the water starts to boil, those particles really start to move. When you turn the heat off, the steam is no longer being created because those particles are not moving as freely, all right, and they start to slow down and they will reform into a liquid. Once you reach the liquid stage, you remove even more heat, all right, which means you're dropping the temperature, all right, the particles slow down and become tightly packed together again. This is called the freezing point. Okay, so the melting point and freezing point are going to be the same temperature when you talk about a substance. For example, water's freezing point is 32 degrees Fahrenheit or 0 degrees Celsius. If you go to 33 degrees, you start to melt, all right, and those particles will start to move a little more rapidly. There is one process where you don't go from a solid to a liquid and a liquid to a gas and reverse. All right, and it's a process called sublimation. There are some things that can go from a solid straight to a gas. And we're going to talk about a few of those substances that can do that. Okay, it does need to be noted that all matter has unique boiling and melting points. So for example, we talked about water in this example. Lead would have a different boiling point and melting point for it because it is a very unique substance.